Welcome to the lecture for Chapter 15 on neck and trunk. Let's start with a little bit of a review here and take a look at a typical thoracic vertebrae. So A, that is your neural arch. B is the body. C is the pedicle. D, vertebral foramen. E is the transverse process. F is the superior articulation process. G is the lamina. H would be the spinous process. Now, if we look at the design of the spine, we need to see that on this image, D is the cervical vertebrae, in which there are 7, and it has an anterior convex curve. C is our thoracic spine. There are 12 thoracic vertebrae, and it has an anterior concave curve. 5 lumbar vertebrae, which is B, and it also has an anterior convex curve. Okay, looking at your notes still, facet joints. They're also known as epiphyseal joints, and there's just a little bit of motion between the superior and inferior facet, and it's not a lot. But what is amazing about the spine is that little bit of motion applied across the kinetic chain, so across multiple vertebrae or even multiple regions of the spine, really increase that range of motion. So while there might only be a little bit of rotation at T3, T4, by the time you add all of those thoracic vertebrae, the lumbar vertebrae, that's when you can really rotate. Now, to distinguish between the superior and inferior articular facets, there's 2 places you can look in the book. So you can look at figure 15-5, and you can also look at figure 15-10. So recall that the spine has 3 planes of motion: sagittal, frontal, and transverse. So the cervical, thoracic, and lumbar, all 3 planes. So like I said earlier, there's only a little bit of motion at each particular joint, but when you add all of those up, that's what creates the great range of motion. So intervertebral discs, which is represented by C in this image, there are a total of 23 discs. So there is no disc between C1 and C2. So each disc is made up of 2 parts. There's the outer portion, which is the annulus fibrosus, which consists of fibrocartilage rings. And then the inner portion is the nucleus propulsus, which is a jelly-like substance. There's actually water in there. The younger you are, the more water there is in each of those discs. As we age, the water has a tendency to leave the discs, and which creates shrinking as we age. So I know for myself, I don't have a disc between L5 and S1, and then the shrinkage that's occurring in my other discs just with age, I am about 1/2 inch, maybe 5/8 of an inch shorter than I was 25 years ago.